Hi, in this lesson we want to take a look at the linear function. Now the linear function is characterized by this formula, y is equals to mx plus c, where naturally y tends to be the output of our function, x tends to be the input of our function, c is our y-intercept, and m is our gradient. Now, the gradient of a linear function, let me just draw a standard linear function. So, a normal linear function would look something like that. So, this is a normal linear function, and there are some characteristics about it that we can note down. So, we have here an x-intercept. Over here we have a y-intercept, and we say the y-intercept is characterized by c. Then we have the difference between the input and the output, which is known as the gradient. So the difference between, or let's say the quotient of the change in the output over the change in the input. Basically, you can call it the rate of the function, because it all measures how fast or how slow the function grows. So something like this, you would say, okay, this function grows slower compared to this one, because for every x value, for every one x value we cover, maybe we cover half a y value for this one. But for every one x value we cover maybe 4 y values for this one. So for a small change in input, we have a large change in output. That's what we call a high gradient. And then for the same change in the input, if we get a small output, a small change in the output, then we can say this one has a low gradient. So low gradient and high gradient. And the gradient formula is written as follows. The gradient is equals to y2 minus y1 over x2 minus x1, where x1, y1 and x2, y2 are coordinates at any point on our function. So getting the difference between our x and the difference between our y, and then finding the quotient of that gives us our gradient. Then there is another formula that you might be aware of, where we have y minus y1 is equal to mx minus x1. This is the same linear function formula, but from the perspective of the gradient. So if we multiply the denominator by x2 minus x1, we end up with this function that we have over here, where we just need to substitute one coordinate and the gradient if we know it, and we can get our standard linear function almost immediately. So this is it about the linear function. There's not too much to say. Just make sure that you understand the underlying concepts and the relationships, rather than just trying to memorize what the formulas are. But all in all, there aren't too many formulas besides this gradient formula.